Hello everyone, welcome back to Practical Serverless and Microservices with C Sharp. My name is Muhammad Abdullah and I created this course for .NET developer and engineer who want to learn about serverless and microservices in C Sharp. So this is section number 3 and if you missed the section 1 and 2, please check out the playlist. So I will share the link in description. So please check the link and first watch the section 1 and 2. So in this section we will cover microservices types and some different patterns. So you can see here we have some front-end microservices and worker microservices. So there is a difference between these two microservices. So the front-end microservice face the client like the user. It's the user-facing microservices that perform the client request and response, and it can also handle multiple parallel requests from different user as well. And thread or request pattern, it follow thread or pattern request. So you can see here in the diagram we have different microservices. Some of them is front-end microservice, like the first query microservice, and at the bottom we can see update microservices. This is the front-end microservices, like it facilitate the user or the client. And the next is the worker. You can see that in the diagram we have in the middle we have worker microservices that only deal the inner communication, like no direct user interaction, only process the data. It work in the assembly line operation, and it also work on a queue-based processing. It perform queue-based processing. So this is two types. One is the front end, the other one is the so here is the example of car sharing application. So in the whole course we will focus on this car sharing application. We will create services for it. In this example you can see here we have like 6 microservices. Routing, location. At the top we have like routing, allocation, best matches, and at the bottom we have car sharing that fulfill the request, car seeking, and route choosing. And in the middle we have the planner, which is the worker microservices. The top three and the bottom three are the other type of front end microservice, and the route planner is the worker microservice. So this is the example of the front end and worker microservice. So next, you can see here a car sharing application. When we do analysis, we find two domain. The first domain represent car sharer language, which represents 6 microservices, and the second domain is the routing language, like the meter route planner. So this is the two domain we will cover in this course. And if we check the architecture layout, the top microservices are the query. It only give data to the user, and the top microservices they are update microservice, update microservice, and the worker microservices in the middle. You can say the gray shaded. So this is the worker microservice. Mostly query and update microservices are the front-end microservices. So this is some indication. So you can see here, this is the car holding journey. Car holding journey, it handle all the crude operation for the car owner and manage trip creation and availability. And it also integrate with route planner. If you check in the diagram, car holder, it also interact with the route, location, and route planner. And route choosing update microservice, you can see here, car holding accept car seeker, select route matching, resource destination, remove incompatible option after match. So this is some information about the microservices we will cover in the course. We will actually practically do this on microservices. Okay, so the car seeker request, if you check the car seeker request, it will handle all the passenger request. It will also do the crude operation like the car holder, and it will also submit the request after date selection. They will select the date and it will send the request. So this is something about the car holding holders and the. Okay, so in this slide we will check the complexity reality check, like some truth about the microservices. Like if in microservices we have like different services on different machine, so the testing become complex. So this is truth about microservices. And the maintainability is time consuming, and complex data driven communication pattern. We will follow complex data driven communication pattern, and it will also increase the cost. So this is some truth about the microservices. So while choosing the microservices, you will also keep this in mind. Okay, so here many people ask question like when to adopt microservices. So here is the some use cases. So if your team is more than 5, you can go with the microservices. And if your application have high traffic and time consuming models are there in the system, so you can go with microservices. And if you need a module level optimization, so you can also choose the microservices. And in microservices we must split the tree, because it will define clear boundaries, and it will avoid ambiguities. So when not to adopt the microservices, if your application is low traffic and you have small team, and the requirement is straightforward, so you can not adopt microservices. So Next, we will cover some patterns in microservices, like why we use patterns. So in microservices, we face different problem. So developer and a programmer create solution for that particular problems. So that solution became patterns. So whenever we face the same problem in our microservice, so we can use the existing pattern instead of creating our own pattern, because the already created pattern is tested and it work for other users as well. So uh, we will cover some microservices pattern, mostly concerned with the resilient task execution, which is the one of the microservices pattern. Okay, so what is resilient task execution? So in microservices, microservices can be moved between machines for load balancing. Okay, so load balancing like distribute traffic between nodes. So, so also the microservices can be restarted to recover from memory leakage and performance issues. And some microservices can also miss some messages during any operation, and it also fail due to software bug or hardware bug. So to deal with this, we have some strategy like failure detection strategy. So in this case, we have two methods. One is unexpected exception, and the second one is the timeout exception. Okay, so we will see that how we can cover this failure. So we have some reliability patterns, reliability patterns. So they have three major standard pattern. The first one is the exponential retry, and the other one is the circuit breaker and bulk ahead isolation. So we will check this one by one. So the first is the exponential retry. So what is the purpose? To overcome temporary failure. Okay, so like when service restart, during that pattern, we implement the retry, and the retry increase exponential number of retry, and when the maximum number reach, we throw exception. So we can use the exponential retry pattern in to get reliability in the microservices. The second one is the circuit breaker. Okay, like when exponentially try reach maximum. In that scenario, we use the circuit breaker. Like a block, we can block access to resource for fixed amount of time, and return immediate exception, allow time for human intervention or manual fixes. And it also circuit breaker also prevent cascading failure. And the third one is bulk ahead isolation, and it prevent failure and cognition propagation. So here is one point. What is cognition propagation? So cognition propagation happen when one service become slow or overloaded. So it start consuming all shared resources of other microservices, like thread CPU and DB connection. Other services that share those resources also slow down. So this is called cognition propagation. So bulk ahead isolation prevent cognition propagation. Okay, and the replica use same database. This example, um, and one replica open too many connection cognition database for all the replica. And what is the solution for this? Is a partition connection. Like we will define maximum number of replica per service. So this is the solution for it. So you can see here we have some strategies, we can limit active request, like only 5 database requests at a time per service instance is allowed. This is one strategy. Second one, extra request, keep the extra request in the line. And the third one is, if the line is too big, the queue of the message, the request is too long, stop accepting more requests. So this is the third strategy. And the four, when return error is instead of crashing. So if there is any bug or crash scenario in our microservice, so instead of crashing, return the error. So this is some strategy to bulk ahead implementation. Okay, so next is the communication pattern. Like we have output input messages queue, which is needed for reliability, and publisher subscriber. We can get the loosely coupling, and the other one is the event-based messaging, which is we will cover this in coming slides. So when we implement the synchronous communication, we face some few challenges. Like keep messages copy until acknowledgement. So we will keep until the consumer of the message is does not implement or accept receive that message. We can enable retry operation, handle communication failure. And the second is the message duplication. In many scenario, this is a challenge in the synchronous communication, like message duplication. And the other one is the message order. Like message can uh, arrive out of order, and wrong order can cause data consistency. So this is a few things, few challenges we will face in asynchronous communication. So what is output message queue solution? What is the solution for output message queue solution? So here you can see in the diagram, queues all output messages. We will keep all the messages in a queue, and when any consumer acknowledge the message, just remove the message from the queue. And if any message fail or time out occur, so just requeue the message. and include attempt number of exponential retry. So we can add the retry mechanism, and store minimum retry time per message. So we can also define minimum retry time for each message. Okay, so this is output message queue. The other one is the input message queue solution. Okay, so here you can see recognize and discard duplicates. So in this pattern, in this communication pattern, we will avoid to duplicate. We will recognize and discard the duplicate messages, and we will reconstruct the correct message order. And what is the processing rule? Read message only after filling sequence call. You can see here in the diagram. And what will be the result? Order. We will keep the messages in order, and the duplicate free message processing. So this is what we can get from the input messages queue. It will remove the duplication, it will give order. Okay, in event-based communication, we face some challenges like want to add a statistic. If you want to add a new microservices like that will give you statistics to the car sharing example I shared in the previous slide. So what will be the problem? These statistic microservices need like some data from the existing microservices. So what you will do, you will modify the source microservices. So if you do this, you will violate the modification should not propagate principle. So what is the solution for this problem? The solution for this problem is the publisher subscriber pattern, which is the another communication pattern. Okay, you can see here in the diagram, sender send message to the publisher endpoint. There is no direct communication reception, and interested microservices like recipient one to subscribe to that publisher endpoint, and publisher automatically forward message to all the subscriber. And new microservices, what will the statistic microservice will do? It will just subscribe to that pattern to receive the messages. So in this pattern, we can get the microservices independency maintained. So we can get the each module will be dependent. Okay, so for this we can to also use the message broker like handled by application called message broker. We can use the message broker like in market we have RabbitMQ and Azure Service Bus, which offer a publishing message, and it will deliver to all the subscriber. So this is a message broker, and here is the summary. To get the resilience in the microservice, we will follow some patterns like exponential retry. It will use for temporary faults, circuit breaker, long-term failure, and bulk head isolation failure contentment, and some other communication patterns like output input messages queues. We can get reliability. Publisher subscriber, we can get the loosely coupling in the event based messages. So this is all about the. Okay, in the next section we will cover the Docker and Onion architecture. And if you are new to this channel, please subscribe, and if you have any questions, so you can ask in the comment. Thanks for watching.